All right, stats. I don't know about you, but I am happy to be at chapter 3 with all that writing of sentences and whatnot, and excited to be on to chapter 4, which is about probability. The reason is, I think we know some things about probability, so it should be a good chapter. Now, we do a little bit different stuff in this chapter as well, but again, a lot of it, or some of it, should be review from before. So, section 4.1 is titled Randomness, Probability, and Simulation. So, the probability, we'll talk a little bit about. This idea of randomness we'll talk about as well. So, like, we talked about random samples already. And then simulation, we've talked about simulation and what we use simulation for. So again, we'll just keep branching off on that. All right. So first of all, there is an activity. So you need to pause this video, get out of here and go do this activity, and then come back and learn about some probability. Okay, so hopefully you're back from the activity. So again, we need to note that chance behavior is unpredictable in the short run, but has a regular and predictable pattern in the long run. So again, this idea of chance behavior in the long run. Now, when you did the coin flipping, again, you could have gotten maybe 3 heads in a row for the first 3 or 3 tails in a row, right? So that's unpredictable, right? To get heads, or tails. But again, if you were to flip the coin enough times, so again, the last thing you had to do was flip it 500 times, right? You should see that, again, it averages out. It becomes predictable in the long run. So what is probability? The probability of any outcome of a chance process is a number between 0 and 1 that describes the proportion of times the outcome would occur in a very large number of repetitions. Again, that 0 to 1, those are proportions. 0 to 1 is also 0% to 100%, right? If you wrote it as a percentage. But again, think of it as a proportion, all right? And then again, the law of large numbers here says if we observe more and more repetitions, the proportion of times that a specific outcome occurs approaches its probability. The proportion will approach its probability. Think of this in terms of sample size, right? We just got done with chapter 3, and we learned that if you increase the sample size, you approach or become closer to the true value. Same thing here. If you increase the number of times you do something, you're going to approach its probability, which is, in a sense, its true value of occurring. All right, so example 1, who eats breakfast? According to the Book of Odds, the probability that a randomly selected U.S. adult usually eats breakfast is 0.61. Part A, what? Explain what probability of 0.61 means in this setting. So again, when we do a lot of interpretations, we usually interpret it in terms of a percentage. So 0.61 is really 61%. So I'm going to say if you take a very, very large random sample of U.S. adults. So again, we need this very large random sample because we need many repetitions, right? If you take a very large random sample of U.S. adults, and then we say about 61%, not exactly 61%, but about 61% of them will usually eat breakfast. Okay. So again, it's very important to include this very large, right, random sample. And again, this idea of about, because it's not exact, it's always about, right? Probability is not exact. And then part B says, does this probability say that if 100 U.S. adults are chosen at random, exactly 61 of them will eat breakfast? Again, this word exactly is a little bit harsh. Now again, what is 61 out of 100? Well, that's the 0.61. So they're trying to take this probability very literally. You can't. No. Probability. Probability describes what happens. in a very large number describes what happens in a very large number of repetitions. And I think it's an E, repetitions. Sorry, like repeat. So because of this, we would expect to get about, and again, there's a word about, right? About 61 U.S. adults who usually eat breakfast out of a random sample of 100. Okay. Note, probability describes what happens in a very large number of repetitions. We would expect to get about 61 US adults who usually eat breakfast out of a random sample of 100. So again, 100 is not a big enough sample to be exact, right? And in theory, there is really no big enough example or big enough sample. But again, we're just looking for a very large number of repetitions. All right, that's objective 1. Objective 2 is coming up next.